Hello friends, in the last lecture we have discussed about how the instructions are executed in your computer. Today we are going to talk about the instruction set which is used. Uh, the instruction set has your instructions, those instructions which can be executed by your processor. So see, the operation of the processor is determined by the instructions it executes, referred to as machine instructions or computer instructions. The collection of different instructions that the processor can execute is referred to as the processor's instruction set. Remember this point, what is a processor's instruction set? The set of instructions which can be executed by that processor, that will be called as the instruction set. These are the elements of machine instruction. One more thing you should remember is whatever instructions are being executed, those are machine instructions and not high level language instructions. So when you write any program and you execute that program, what happens is the compiler first converts your high level language program into machine level language program, and then only those machine level machine instructions get executed by your processor. So let's just talk about elements of a machine instruction. First element is operation code. This operation code specifies the operation to be performed, and this code is specified by a binary code, or we can call it as opcode, as we have seen in the last lecture when we talked about the format of an instruction. First part is for your opcode and the remaining part is for your instruction. The addresses. Okay, so in next element is source operand reference. See, whatever operation we are talking about, that operation may involve one or more source operands. That is, operands that are input for the operation. And next one is result operand reference. So whatever operation you are doing, that operation is going to produce some kind of result. And where do you want to store that result? That is called a result operand reference. And last one is next instruction reference. This reference tells the processor where to fetch the next instruction after the execution of execution of this instruction is complete. So these source operand and result operand. Source operand means whatever you are giving as input, and result operand is whatever you have calculated in your processor after performing those operations. That will be your result operand. These can be stored in following areas. First area is main memory or virtual memory. Second one is processor register. You can also say the source operand or result operand. They may be in processor register, or immediate means if your processor has only one register, then that will be implicit, that you are going to store that operand into that register. And last one is IO device. Or you can fetch the source operands from your input output devices, and or you can send the result operands to, or save the result operands into output devices. So that is possible. So your source and result operands can be found in any of these four areas. Now let's look at a simple instruction format. See, this is a simple instruction format. This has total 16 bits. Out of these 16 bits, 4 bits are allocated for specifying the opcode, and in remaining 12 bits, 6 bits are allocated for operand reference, and these 6 bits are allocated for another operand reference. Now let's see how the instructions are represented in your machine level language. So the instructions will be represented something like this. So if you want to add two numbers, that will be ADD. So we are just using short forms. If you want to subtract first number from second number, then the instruction will be SUB. If you want to multiply two numbers, the instruction will be MUL. Okay, and so on. If you want to load the data from memory, then you have to use load instruction. If you want to store data to memory, then you can use store instruction. Now, after talking about this, let's talk about what are the types of instructions. I think we have already discussed this, but let's just repeat one more time. First type is data processing instructions. So data processing instructions will be something like add, subtract, multiply, divide. Okay, so you are actually processing data in this data processing instructions. But in case of data storage instructions, you are storing data. So data storage instructions will include instructions similar to store instructions. Now, next is data movement instructions. Data movement instruction, it's something like this: load. You are copying data from memory into your processor's register, or you are copying data from one memory location into another memory location. So these will be data movement instructions. Next type is control instructions. Control instructions actually decide the flow of your program, and so these control instructions include the instructions like conditional instructions. If the condition is true, you have to execute some part of program. If the condition is false, you have to execute another part of the program. Or the loop instructions, in which you have to check the condition and decide where the next instruction should be, from where the next instruction should be fetched. So these kind of instructions will be called as control instructions. So that was the classification of instructions based on their operations, what kind of operations are being done by those instructions. The instructions can also be classified into another 3 classes based on number of address fields the instruction has. See, we have just seen this instruction format. Here you have 2 address fields. So this will be called as to address instruction. But if the instruction has only one address field, that will be called as one address instruction. If the instruction has three address fields, it will be called as three address instructions. Let's just see some examples. See, uh, here you have three address instructions, here you have two address instructions, and here you have one address instructions. Let's start from one address instructions. Okay, this is the operation we want to execute. Okay, so first you have to subtract b from a, then you have to calculate the denominator, and in the denominator you first have to perform this multiplication and then add this multiplication to this c, and after that you are going to divide this a minus b by denominator. Okay, the calculated denominator. Let's see how it is implemented in this example. So at first what we have to do is, see, we are first starting from denominator. First load d. So whatever contents of d are, we're going to copy those contents into accumulator. Okay, see here when I'm saying this is one address instruction, we are considering that there is only accumulator register available in the processor. Okay. So next thing is multiply by E. That means whatever the contents of AC are, multiply those contents by contents of E and store the result into AC again. Okay, then next thing is add C. So we'll be adding contents of C into contents of AC. Okay, so at this step you have your denominator. Okay, now what we are going to do is we are going to set aside this denominator, store into y. So whatever contents of AC are, we are going to transfer those contents into y. Now next instruction is load A. Means you are going to copy contents of location A into accumulator. After that you are going to subtract B from A. So contents of B will be subtracted from contents of your accumulator, and the result will be again stored in your accumulator. Next thing is divide. Divide by y. See, in y you have your denominator. So divide this a minus b by y. So after dividing the contents of AC by y, you are going to store the result into AC, and now you have got the result in your AC accumulator register. So we are going to store the result into y, store into y, another location. See, what we have done here is we have specified the locations by using these letters. Okay, let's just say I have given that those locations names, memory locations, I have given names. Okay, and in this way I have specified the memory locations. Now count the number of instructions we just needed for calculating the same polynomial when the instructions were one address instructions. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now let's go to two address instructions. When we have two address instructions, first see, look at the instructions. Move y and a. That means move contents of a into y. Now next is here we are not actually going to use only one register, one processor register. We can use more than one registers because we have two address instructions. So at the next step, you are going to subtract B from Y. And we are going to store that into Y. Okay. Now move T into T comma D. That means we are going to move contents of D into T. See, here we have started from the numerator. We have first calculated the numerator. Now we are going to calculate the denominator. We already have T into your T memory location. Next is multiply that D by E. Okay. So T multiplied by E will be stored in again T. And what we have to do is again add C to this multiplication. So add C. Okay. So T plus C will be stored in again T. So your denominator is in T and in your numerator is in Y. So divide Y by T. And this is your result. The result will be stored in Y. Okay, now we'll count the number of instructions 1, 2, 3, 4, 5, 6. See, as we are increasing the number of address fields, the number of instructions are decreasing. Now let's see how three address instructions work. Uh, so here you have from where you want to fetch the operands and where you want to store the result. So this instruction subtract y a b means subtract b from a and store the result into y. Again, in this case, mpytde means multiply d and e and store the result into t. Add ttc means add t and contents of t and c and store that into t. Last and c. Now you in t you have your denominator, in y you have your numerator. So again you have to divide y by t and you will get your answer for this polynomial. Okay, now again count the number of instructions 1, 2, 3, 4. So here the instructions were 8, here it was reduced to 6, here it is reduced to only 4. So as you increase the number of address fields in your instruction, the number of instructions needed to perform a certain task that will reduce. Okay, so it's kind of like inverse proportion. That is one important thing to remember. And your homework is to calculate, you have to write um, all these types of instructions: one address instructions, two address instructions, three address instructions for any polynomial. You can choose any polynomial. It should at least have 5 quantities. Okay, you need to have minimum 5 to 6 quantities, and there should be at least 4 operations. Okay, 5 quantities and 4 operations. Choose any polynomial. You can take any polynomial you want and something like this, and write programs by using one address instructions, two address instructions, and three address instructions. This is your homework. Okay, so complete this homework and we'll discuss the remaining part in our next lecture. Thank you.